All right, so let's continue chatting about the place value system as we look to develop a deeper number sense. Today we're going to shift gears and we're really going to build off our last learning target where we kind of talked about the relationship or the pattern established between each place value position, to where we seen that if we move to the left on our place value chart that we are seeing it multiply each time by 10, and vice versa. If we move to the right on our place value chart, we are seeing it divide by 10 or multiply by 1/10 each step down. Today we're going to focus on powers of 10. After this lesson and some practice, you should be able to use whole number exponents to denote powers of 10 and explain patterns of zeros when multiplying by patterns of 10. So let's jump into powers of 10 today. This should be a shorter lesson, which is tough for me to do because I am so long-winded. But some of this you may already know. So let me kind of just start with, and let's talk about, we're going to talk about the exponent itself. So when we talk about the word exponent, what exactly are we talking about? An exponent, you're going to see, and with what we're doing today, we're going to see in powers of 10, which mean that we're going to have a number like this. So we're going to see a 10, and then on the 10, we're going to call this here, this is called the base, okay? So this is the base. It's the base number. And then we're going to see an exponent, which is a number that is written, it's smaller and it's elevated and it's written to the top right side of the number. Kind of if we were at using an analog clock, it's kind of at the 2 o'clock position. And it can be any number up here. And then this number here, this is called the exponent. Now the exponent is a power, it's a function, and what the exponent tells us is that it says it is the base, which we'll let be b, times itself this number of times. So for this particular one, it would say base times base, because it is 10 times itself twice. So, and you're going to hear a lot of different expressions when it comes to exponents. You're going to see here 10 raised to the second power, or 10 squared for the number if you see 2. If it were 10 to the third, you would see 10 cubed. So there's a lot of different expressions of exponents as you kind of grow into this mathematical understanding. But for all intent purposes, what I need you to understand, it is the base, whatever this number is, times itself. What you don't want to do is to assume that that is 10 times 2, because it is not. When we see 10 to the second, it is 10 times 10, which would equal 100. Okay, so that's kind of what the exponent is. And let's take a look at a couple, and I'll give you a few moments to just kind of process this. So a power of 10 is, and we'll look at some examples. So how about this one? 10 to the fourth. Let me make that bigger for you. Okay. So we have 10 to the fourth. Now I want you to stop and think. I'm not asking for an answer. What I would like to say, what is it? What expression? When I say expression, this means what? So meaning that there is something here we're going to look for, and then we'll look for the answer over here. So here's my answer. Wow, you see that? That's summer brain getting after you right there. Here is my answer. Okay, and then right here I'm looking for an expression. Okay, so what is it? Well, it's base times itself 4 times. So 10 times 10 times 10 times 10. That's the expression. That's what that means. 10 times 10 times 10 times 10. Now, if you went to solve it, what is 10 times 10? Right, this would be 100. Multiply that by 10. Well, what's 100 by 10? That would be 1,000. And then that times 10, right? Because I'm getting rid of these here. and then that would be 10,000. Now, strategy, very important here, okay, is notice here, how many zeros are here? 1, 2, 3, 4. Count here. 1, 2, 3, 4. So you can essentially take it, and again, strategy is that you could say this exponent can tell me only when this is a 10, when the base is 10, the exponent can be the number of zeros in the answer. So seeing it that way, think through this. And let me kind of clear this up for a second. So think through that. Only when it's 10, and I can't stress that because it's not the same if the base changes. But if I say 10 to the third, you don't need the expression part. Just I want you to quickly think. Remember that if the base is 10, the exponent is the number of zeros in the answer. So then I could say, well, that's 1, and then how many zeros? 1, 2, 3. 10 to the third would be 1,000. So that's essentially what we look like at exponents with a base 10. And we're raising it. So now let's step it up a notch and say, well, what if this happens? I want to take 62 times 10 to the second. Okay? Now we're going to use this, and we've got to kind of have an understanding to say, well, what exactly does this equal? Now here is where, again, you come back to that place value chart that we were talking about in the previous lesson. Okay? So I come down here and I have a place value chart. And my 62, I'm going to need ones, tens, hundreds, thousands, 10,000s. 60, look at me. 62. Now, how far am I moving it? Well, I know that this is equivalent to what? 10 times 10, which equals 100. So to move it 100, remember multiplication, the numbers, the digits move to the left. How many places to the left? 2 places. 6, 2, fill the rest in with zeros. 6,200. Now look, you see this? This is me showing my work. That's me showing my understanding. I am showing you that this here is how it worked. I moved it. Now, again, come back to strategy. Is there a decimal? I've got the 62. Is there a decimal there? Absolutely there's a decimal. Even though we don't write it, it has always been there. We just don't simply come to terms with the decimal until we begin to learn about what's behind the decimal. But the decimal's always been there. That decimal says, hey, that is 62 whole somethings, right? Now, I can, if I bump them over, okay, can I add zeros to this, right? Can that decimal move this way? Twice. Why twice? There are 2 of these. Every time it moves over, I got to have a 0 placeholder. So some people will teach you a strategy where it's not the numbers that move, it's the decimal that moves. In fact, your parents might tell you that because that's how they were taught. That's how I was taught. I was always taught that it's the decimals that move, not the digits that move. But reality is that in a place value chart, it stays stationary, and we see the numbers shift back and forth in there. So it's a higher understanding of the math when you understand that the numbers and the digits are what are moved from left to right based on the operation. But a good strategy, which is what we were taught, which is an excellent strategy, is that you can learn that decimal does move. So you grab the decimal, move it the number of places that the exponent says. Okay? So let me show you that one, and we'll just talk strategy only here, okay? So with strategy only, what if I have this number? Okay? So I have 2 4/10 times 10 to the third. Now we can quickly, just for understanding purposes, we know 10 to the third is really times 1,000. Things that I know multiplication tells me that the digits move to the, think about it, to the left. But in my strategy, I'm going to say, well, my strategy tells me that multiplication means the decimal moves to the right. And you can always think about it, it's opposite. So if multiplication moves the digits to the left, then the decimal has to move to the right. If division moves the digits to the right, the decimal move to the left. But I can do that likewise. I can come over here and show my work. 2 4/10. The decimal's going to move to the right. How many times? 3 times. There's 1, 2, 3. So the decimal's now here. And my answer would be 2,400. Okay? You want to prove it? Let's draw our place value chart. Is that enough places? Yeah, it should be. Okay. So again, I've got my 10th, my ones, 10, 100, 1,000. My original number is, we know big decimals right here. My original number, let's change our color so we can see it, is 2 4/10. Again, our rule is that multiplication moves the digit to the left. How many times? Well, 10 to the third, which is 1,000. So there are 10 times 10 times 10. So times 10 times 10 times 10. There's where my 2 goes. Everything kind of follows suit. Fill in the zeros back to the decimal. And so that's how I show it. So again, here is, strategy. And strategies work, using strategies. And then this here is more concepts. Okay? Now, hear me. Strategies are great ways to solve problems, and strategies provide you with correct answers. However, concepts and being able to show concepts are what show you or would drive your ability to show, not you, but show your audience your understanding. So you definitely want to know how to show that on a place value chart and show how those digits do shift to the left and to the right. So let me do one more example because I really want to hit into division before we sign off, and then I'll be done with you. So let's talk division. What if I have a number such as 5, we'll go 523 8/10, and we're going to divide it by 10 to the second. All right. So quickly, and again, what I want to do with this one is I definitely want to just show you. We'll go, and big S will be strategy, and then C will be concept. So I'll show you both ways of doing it. Okay. So we'll talk strategy first. Let's just come on over, and I'm going to rewrite the problem. 523.8 divided by. Actually, I don't have to put the divided by with this. If I'm working the strategy out, and I'll show you why. So I write the number, and what I know is that the division tells me what? Well, it says, hey, your digit moves to the right within the strategies rules. That means the decimal moves to the left. How many places? 2. So see that? 1, 2. So now the decimal's there, which would tell me my answer is 5 238 thousandths. See, all I did was rewrite the number, shift the decimal the correct way. One of my warnings about using the strategy is be careful and not let the strategy mix up how you understand the movement of these things. Now we'll come over to the concept, and let's get us a quick place value chart. Notice my place value charts aren't perfect. They don't need to be. This is stuff you'll show on scratch paper, and I wouldn't get overly worried about what that looks like. I think I might need another one. All right, so turn that off. So here we've got our, start with the original number. So we've got our hundreds, tens, ones, and then decimal. We've got tenth, hundredth, thousandths. Okay, so my original number needs to get plugged in there first. 523 and then 8/10. Now again, go back to our original, the rules. If I'm dividing by powers of 10, which I am, that the digits move to the right. Well, how many times do they move to the right? Well, this is going to tell me they move 10 times 10. And in this fact, when they're moving to the right, it's actually this, right? Why is it that? And it's because of that. So this equals 10 times 10. But the direction says, hey, well, you're actually, as you move that way, you're actually going by that. So hopefully that's not too confusing. But what basically this tells me here is how many places am I going over. So I'm just going to start with my most far right number, okay? So that's going to come over 1 time, 2 times, and drop down, 8, and then just let everything else, and see, exact same answer. But again, this concept is what I'm showing, the strategy. Both give me the right answer. But, my fear is when you don't allow the strategy to be your explanation of the concept, because in that you're going to talk about decimals moving, and it's not going to be as sophisticated as if you talk about the digits moving. The digits move in these powers of 10. So that's a wrap for today. Hopefully you have a little bit better understanding of how to use whole number exponents and be able to explain how those zeros impact the way numbers shift on a place value chart. So that's a wrap. Till next time, talk to you soon.